idea that you'll understand.
My name is Michael
When
Bryan
you
the
look at
second.
functions being
This is
one-to-one,
Challenge 2016,
and this is also an
this is
example of a
Calculus
function that is
1000.
onto, which means that every
So,
element
first of all,
also
a
matches with
function
every
is one-to-one
element from a
when
second
f
function.
of a is equal to f of b, where a is equal to b.
Although a
Which
function being
essentially
one-to-one
means that
of all
is
the
usually
elements in the
defined by
two
looking at a
functions,
function such
no
as that.
element B is
There
an
is
image of
also
any
another
other
way to
element
test
than
it
one
when
of
looking
A.
at a graph.
As you can
The
see by the
function
image
must
drawn
also
below,
pass the horizontal line
1 goes
test.
to A, 2 goes
Essentially,
to
if a
B,
horizontal
3
line
goes to C, and
interacts
4 goes to D.
on a function graph more
This
than
is
once,
generally
it is
the
not
idea
one-to-one.
that you'll understand.
So looking at the graph
When you
below,
look at
you can
functions
see
being
that
one-to-one,
on the function,
and this
the
is also an
horizontal line
example of a
crosses
function that is
right
onto,
near the
which means that
y-axis
every
when
element
x is equal to
also
0,
matches with
and
every
further along
element from a second function.
on the x-axis. Because the horizontal line crosses these
Although a
2
function
points,
being one-to-one
it actually
consists
is
of
usually defined
3
by
points,
looking at a function
once
such as that.
the line crosses
There
these 3
is
points,
also
it
another way to
indicates
test
that
it when looking at a
of
graph.
the elements in the
Function
function,
must also pass the horizontal
at
line
least
test.
one, or in this case
Essentially,
3,
if a
because a
horizontal
line
line
matches with
interacts
another
on
value,
a function graph
making it
more than
not
once,
one-to-one.
it is not one-to-one. So looking at the
We now
graph below,
have an
you can see
example,
that
moving
on the
on from
function, the
one-to-one,
horizontal line
the
crosses
horizontal line test
right near
of
the
a function
y-axis
when
and
x is
how
equal to
to
0,
obtain its inverse.
and further along
So from you can see the function we
on the
have is y
x-axis.
equals x
Because
squared
the
plus
horizontal line
1
crosses these 2
when
points,
x
it
is
actually
less than or equal to
consists
0,
of 3
which
points,
essentially means that
Once the line
this
crosses
graph
these
is
3
being
points, it
restricted to the negative
indicates that
side,
of the
or
elements in
when
the
x
function,
plus at
when y
least
equals x
1,
squared plus
or in
1,
this case 3,
any
because
value
the
that's
line
not on the negative side
matches with
will
another
not be
value,
consistent with this function.
making it not one-to-one.
We
Alright,
now have
so
an
we have our
example,
function y
moving
equals
on
x squared
from
plus 1
1-to-1, when
and
x
horizontal
is
line
less
test
than or equal to
of
0.
a function,
So,
and
the
how
first
to
step
obtain its
in finding the
inverse.
inverse to a function
So from
is
you
to
can see the
switch
function we
y
have
and
is
x
y
values.
equals
So
x
as you can
squared
see,
plus
we've done
1
here. We
when
now
x
have y
is
minus
less
1
than or equal to
is
0,
equal to x squared.
which essentially means that
So we take this
this graph
and
is
then we
being
proceed
restricted to the
to
negative
do
side,
normal order of
or
operation
when
when x squared
x plus
x and
when y
square
equals
the
x squared plus
y
1,
minus 1 in
any
order to
value that's
balance the
not on the
equation.
negative side
This gives
will
us
not be
x is equal to
consistent with this
plus or
function.
minus the square root of y negative 1. Now we
Alright,
look at the final
so we
value
have
and
our
we see
function
that
y equals x
we
squared
have
plus
x
1
equals negative
when
square
x
root
is
y
less
minus
than or
1
equal to 0.
when x is greater than or
So,
equal to 1.
the first step
And
in
this is
finding the
essentially
inverse to a
because,
function
like stated
is
before,
to
our
switch the
graph is
y and
being
x values,
so as you can see we've
limited
done here.
to
We
the
now
left
have
side
y
because
minus
x
1
has to be
is equal to
less
x
than or
squared.
equal to 0.
So we take this and then we proceed to do normal
This
order
is
of
the final
operation
graph of both
and we square
functions, with the blue line
x and square
representing
the
y
y
equals
minus
x
1 in
squared
order
plus
to
1
balance the equation.
when x is less
This
than
gives us
or
x is
equal to
equal to
0,
plus or minus
and the
the
red line
square root of
representing our
y
new
negative 1.
function, x is
Now we
equal
look at
to
the final
negative
value and
square
we see
root
that
of y minus
we have
1
x
when
equals
x
negative
is
square
greater
root
than
y
or equal
minus
to
1
1.
when x is greater than or equal
As you
to
can
1.
see,
And this is
the new
essentially because,
graph, like stated before,
almost seems
our
to be
graph is
a
being
reflection about the
limited
y-axis
to
and then
the
a
left side
rotation
because x has to be less than or equal to 0.
Now we're going to talk about tangent and how on
This is
its
the final
domain
graph of both
it is not
functions,
a
with the blue
one-to-one
line
function.
representing
If you look at the
y
graph below,
equals
you
x
can see
squared
that I've
plus
already
1
done the
when x
horizontal
is
line
less
test.
than or
And
equal to
immediately
0,
from that, you can
and the
see
red line
that
representing our new
in
function,
multiple areas, the
x is
horizontal
equal
line
to
crosses
negative
the
square
various
root of y
functions
minus 1
of
when
tangent.
x is greater than
This
or equal
means
to 1.
that whenever tangent is
As you
performed
can
as an
see,
operation,
the
unless it's
new
being
graph
restricted to a certain domain, which we will
almost
talk
seems to be
about in a
a
minute, reflection about
it
the
will never be able to be
y-axis
a
and then
one-to-one
a
function.
rotation. Like I said,
Now
unless
we're
being
going to talk
restricted
about
to a
tangent and
domain,
how on its
tangent can
domain
never be a one-to-one
it is
function.
not a
But now,
one-to-one
as you
function.
see, I've drawn
If
two
you look at
purple
the graph
lines in
below,
order
you
to
can see that
restrict
I've already
one
done the
of our functions of
horizontal line
tangent.
test.
And so
And
now we have
immediately from
restricted
that,
to
you can see
negative pi over 2
that
and
in
pi over
multiple
2.
areas, the
This
horizontal
means
line
that
crosses
any
the various
operations performed
functions
in this
of
domain
tangent.
will
This
all
means
represent
that
a
whenever
one-to-one
tangent is
function
performed as an
as
operation,
performing the
unless it's
horizontal
being
line
restricted
test.
to a certain
No
domain, which we
one
will talk about
element
in a
of A
minute,
will equal
it will
a
never be able
multiple
to be
element
of
of
B.
one-to-one function. Finally, we have our domain
Like I
and
said,
range of arc
unless being
tangent or
restricted
tangent
to a
inverse.
domain, this
Tangent
is to
can never
show
be a
that
one-to-one function. While
now, as you see,
tangent I've drawn
on
two
its
purple lines
domain.
in order to restrict
If not
one
restricted,
of our
can be a
functions of tangent.
non-function.
And so now
Arctangent,
we've restricted it to
when
negative
restricted,
pi over 2
will always
and
be
pi
an
over 2.
increasing number.
This
Its
means
domain
that
is all real
any
numbers,
operations
and its
performed
range
in this domain
is negative 2
will
pi to
all
pi over 2,
represent a
which we will
one-to-one
see by
function
demonstrating the
as
unit circle.
performing the horizontal line test. No one element of A
As you can
equal
see from the unit
a
circle,
multiple
we have
element of
pi over
B.
2 and 3 pi over 2,
which is also equivalent to
Finally,
negative pi
we have
over
our
2
domain
marked.
and range of
The arc
that you can
tangent
see
or
basically
tangent
represents
arctangent.
This is to show
Anywhere
that
from pi over
while
2 to
tangent
3 pi over 2,
on its domain,
you can see that
if not
arctangent will
restricted,
always
can
be
be a
increasing.
non-function.
Arctangent,
No matter what point,
when
as
restricted,
it tends
will
to
always
lead
be
toward
an
positive
increasing number.
infinity. Its domain is all real numbers, and its range is negative 2 pi to pi over 2,
This
which
is
we will
another
see
graph
by demonstrating
demonstrating
the unit
the
circle.
always tending towards positive infinity value of the arctangent.
As you can see from the unit circle, we have pi over 2
from negative 10
and
to
3 pi
10 on the
over 2,
x-axis,
which is
from
also
the
equivalent to negative pi over 2 marked.
to pi over 2.
The arc that you can see basically
Arctangent
represents
always
arctangent.
increases as
Anywhere
it reaches
from
the asymptote
pi over
of
2 to
the
3 pi over
function.
2. You can see that arctangent will always be increasing no matter what point, as it tends to lead toward positive infinity.
This is another graph demonstrating the always tending towards positive infinity value of the arctangent. As you can see, although it's going from negative 10 to 10 on the x-axis, from the negative pi over 2 to pi over 2, arctangent always increases as it reaches the asymptote of the function.